Before I get to the talk, I'm just going to whore myself out a little bit. So I wrote this book, and I actually have to call out Trotter Cashin, Brian Helmkamp, and Jake Howerton, who each also wrote a chapter because they're awesome. But I have one more to give away, but it's a future book, obviously. So my editor promises to send you one once it goes to print. So the first person to yell this out will get it. Oh, that didn't go very well. I heard somebody over here. All right. It's your lucky day. Rosetta Stone and a wonderful book in August. Anyway, so the talk is about, web services, obviously. And it's also about ActiveModel. But beyond that, it's about creating web services and how you can use web services to abstract complexity in your application so you can achieve scale. Now, when I talk about scale, I'm not talking about like a lot of requests and a lot of traffic. I'm actually talking about scaling with complexity. So as you get a larger code base, it gets harder to scale that if everything's contained in one app. And then also scaling with team size. So I guess, how many people in here have like teams of 10 or more? So not that many, some. But yes, if you have a lot of people all working on the same code base, it becomes hard to manage, which is basically my contention that monolithic applications don't scale. They don't scale to large teams, and they don't scale to really complex, large projects. So with web services, you have to split everything into logical parts. So it's about that. And it's also about how Active Resource killed my best friend. And my best friend isn't this, but my best friend is actually understandable code. So the thing is, when you're writing client libraries, your primary goal is to write readable and maintainable code, right? And you also, if we're talking about HTTP services, you want to be able to make parallel connections, neither of which Active Resource actually lets you do. And another thing you need to do is you need to make stubbing easy for development mode. So when you have, say you have like your Rails app and like 3 web services, it really sucks if every developer has to be running every single web service on their system just to run the app. So you need to make sure your client libraries have stubs in them so that you don't actually have to hit a web service to run development. So let me get into a little bit more detail about what I mean by web services. So there's this kind, which everybody is familiar with, which is external services. So you have your app, and then you have the internet, and then you have things like S3, or maybe the Twitter API, or Facebook, or whatever. But that's not really what I'm talking about. What I'm talking about is internal services. So you have the internet, then you have your nifty Rails app, and then behind that, you have services that serve up the data and the business logic for your app. Now, one of the other things I guess you could also do is you could expose the services to the outside world if you're doing something like Chris had mentioned, like loading data in JavaScript. So you could bypass the Rails app completely. So one of the things that is different about this that you have to be aware of is the fact that you make calls inside user requests. So the calls have to happen quickly. They have to happen, ideally in under 100 milliseconds, so all the other stuff can happen. So the focus of this talk is really on internal services and abstracting complexity so that you can work with large code bases and scale. Again, not traffic. The reason why I'm not talking about traffic scale is because I think NoSQL is starting to get there. Like NoSQL solutions are starting to do a pretty good job of offering us ways to scale the data layer horizontally. So it's really about managing code complexity, team size. So let's talk about some examples when I talk about like abstracting complexity. So think about the processor. Like when you're writing code, assuming you're not writing assembly language or maybe C, most of the time you don't have to think about how the processor actually works. It's this huge abstraction that you're just building on. The operating system, MapReduce is a great abstraction for distributed programming. When you write a MapReduce job, you don't have to think about, okay, how is it going to be distributed to all of these different servers, and how am I going to make sure that I, manage lock contention and all this other stuff. So some examples in web services would be maybe something like an email service. If you have a third-party email service where you just make a web service request to send an email, that can respond quickly. Another example could be a user service. If you have multiple applications and you want to have like one central place to authenticate, you could expose that as a service that you could use. Facebook's Haystack is another example of a service. That's a service that's solely for their photos. And there's a ton of stuff underneath that, but the programmers don't have to think about it when they access the API. That's the only thing they have to worry about is what's the API and just use it. Indexing is another great example. If you're using Solr, you don't have to think about how the indexing works. It's just a service, you make a call. So let's talk a little bit about how to separate functionality. You can partition on iteration speed. So within your app, you probably have different areas of the application that get iterated on quickly. So with web services, you generally want to pick pieces of your app that are fairly stable. They have a well-defined API, and they're probably not going to change that much. That's something that's a perfect candidate for being abstracted out of your main application code base into a web service that can be called. Another thing you could do is you can partition on logical function. So that's kind of like these different objects and models do kind of the same thing. They're within the same logical area, so we're going to group this all together and put it together. You can also partition on read-write frequencies. So web services, obviously, since it's HTTP, they can be optimized really easily for reads. So if you have something that's like read-heavy, then you can pull that out as a service. And one last thing you could do is also think about join frequency. So if you have data split out amongst like multiple services, like eventually you have to join the data together on whatever the foreign keys are. So you don't want to split things that are joined very, very frequently. Like if they're joined very frequently, you either want to keep them together, or you want to replicate the data from one service to another. So the goals with that is to denormalize and replicate the data. And ultimately, what we're trying to do is we're trying to achieve a separation of concerns. There are different pieces of your app, and they're deployed individually. They're abstractions that you can build off of. So active resource and active record, I feel, kind of killed these a little bit. Both of these, thank you. If I had another book to give, you would have it. So both of them make connections inside the model. Now, I'm going to show an example. So I'll tell you a story. Recently, and unfortunately, the Shopify guys are here. I love you guys. But I'm going to use your API as an example. So recently, I had to hit the Shopify API. And I looked in the client gem that they had lovingly provided, and I found this code. Now, base here in this case is a class that they've defined that actually is really just active resource base. And obviously, like looking at that code, like I know Ruby programmers are all into the, hey, you know, you don't have to put in comments, like code is self-documenting, man. Yeah, I don't know what any of these things are doing. But luckily, actually, Shopify provided a great, like they have full documentation on their site so you can see what their API actually does. But I still felt a little bit of rage because, and this is especially true for internal services, very few people are actually going to go to the trouble of documenting an internal service, putting up a web page that says, oh, it does this, this, and this. So if you encounter code like this in a client library for an internal service, you need to go to the service code, look at it. If it's Rails, you have to look at the routes. Then you have to dig deep. Like, you're not abstracting any complexity there. Like, the programmer has to be familiar with how the underlying service works to be able to figure out the API, which is not good. So the other thing that active resource forces you into is it makes requests serially. And the thing is, it's really important to make requests in parallel when you're doing HTTP like services. So let's get on to like the real, I guess, meat of the talk, which is ActiveModel. Now, How many of you have actually like looked at ActiveModel or used it a little bit? Okay. So I'm not going to bore everybody in the room. That's good. So this is what ActiveModel looks like. It's pretty simple. It's actually pretty small. And here are some of the things that it provides you. So attribute methods, which is, it adds some helpers for doing prefixes and suffixes to methods, which I think is kind of boring. Callbacks. So you can do something like this. If you have a user class, you just include ActiveModel callbacks, and then you can do stuff like before create and after create or after save or whatever. It also provides dirty tracking for your attributes. So this is an example that's actually just pulled straight out of the ActiveModel documentation, which is if you have this like person class and you include the ActiveModel dirty, then you can define which attribute methods are tracked, in this case name, and then the only thing you have to do is in the setter you have to be sure to call name will change. And then at that point it gives you a bunch of convenience methods for seeing, 1, if it's changed, 2, if a specific attribute was changed, what it was, and then also like after you save it, then it updates those things. And it also tracks if you set the value to what it was before. So, and then finally you can reset the changes, or and again you can see that it hasn't changed after you've reset. So one of the other things it provides is errors. This is especially useful for plugging in the models that you build just straight into your Rails forms. Like that way it looks exactly like a regular active record object and it can render all the errors. So here's what that looks like. You just define, like, again, we have like this user class. You just define errors. And then the errors object has the standard stuff on it. You can add an error to it, and you can access the specific errors. So it also provides helpers for serialization. You just include the module again, and then at that point you have to have an accessor for attributes, and then you can call to.json or to.xml and have all the standard stuff. So validations, I think, is one of the really like the core piece of ActiveModel that is the best thing that's come out of like refactoring all this stuff. Because it's great to be able to use these validations without having to rewrite them yourself. So we'll go through these a little quickly, but basically you can see like, okay, validates acceptance of, validates confirmation of, validates presence of, validates exclusion of, inclusion, format, length, numericality. And the one thing that's actually missing from this list that you don't see is validates uniqueness of, which kind of makes sense when you think about what ActiveModel is trying to do. Like it's trying to provide an abstraction for basic data model stuff, but the problem is with uniqueness of is it's kind of specific to whatever the underlying data store is, right? If you're using MySQL, then it's going to have to, acquire a lock on that value. But if you're using a web service, you'd have to implement something where you can make a request to get a lock on whatever it is that you need to be unique, and then do the write. And this is to break up the code. Sorry, there's a lot of it. It also has something, a lint test in it for verifying that you actually conform to everything that an ActiveModel model is supposed to do. And it's actually really simple. So you just create a test case, you include the lint tests, and you define this setup method. And at a minimum, this is what a class looks like that will actually pass all those tests. So it includes the conversion module, the extends naming, it defines a valid method, it defines an errors method, and it defines persisted. So now that's like all the ActiveModel stuff. So I want to talk now about parallel connections in HTTP. So there are a few different ways of doing parallel connections. One of them is asynchronous, and well-known examples of how to do that are Event Machine or libcurl multi, curb or Typhoeus. And And Typhoeus is actually one that I wrote while I was working at a company called No More. And it is essentially just a wrapper around libcurl and libcurl multi. So here's a quick example of what that looks like. So basically, I had created this example for the book that was like a social feed reader. So if we're going to break this out into different services, I said, OK, I'm going to have a service that tracks a user's reading list. I'm going to have a service that just stores the feed entries for the system. And I'm going to have a service that stores like all the votes and rating data, right? So this is what that looks like. Now, one of my gripes about Active Record and about Active Resource is that they actually make the connection to the data store for you. And I don't think that's their responsibility. They should simply be data objects with business logic in there. But the thing that makes the connection should actually be, I think, in the controller. So this is what that would look like with an ActiveModel one, with like a web service ActiveModel based system. So in this case, we're saying get the reading list for the user Paul and include entries and ratings. And then what that does is it queues up a bunch of requests in there, but it doesn't actually make them. So then the call to hydra.run will make the request. Hydra is the connection manager object in Typhoeus. So at that point, you can scroll through the reading list and actually do stuff. So here's what that looks like inside, like under the covers. Here we can see that for user is a class method, and really all it's doing is it's creating a request object, and it's assigning an onComplete handler to it. So once the request is complete, it will actually go through. Now in this case, the reading list is the first thing that has to be retrieved, so that can't happen in parallel with anything else. But the fetch of the entries and the fetch of the ratings can happen in parallel as soon as the reading list has come back. So it does that. It says, get the ratings and get the entries. And here is what actually the call to get the entries looks like, which is, again, just make a request, create an onComplete handler, and queue it up. Again, there was a lot of code, so. So the other method is the threaded method, which I would say is really only a viable option on JRuby, because Ruby 1.8 has green threads, and 1.9 has the global interpreter lock. So with JRuby, what I'd recommend is actually using some of the stuff in java.util.concurrent. So it's this whole section of Java that's designed for writing threaded concurrent code, which can help you out a bit. So with this example, again, we have like a request object that represents the request we want to make. It includes this thing called callable, which is an interface that says you have to define a method called call. And in this case, all it does is it uses net_http_get and grabs it. So then once you have that request object, you can actually create a thread pool. In this case, we're saying create a thread pool with 50 threads. And if you're going to do threaded, like the multi-threaded model, like you want to keep that thread pool somewhere usable so that you don't instantiate it on every single request, because that's bad. But here in this example, we're looping through 100 times, and we're saying, get this thing. And then we loop through what these things are called futures, which is kind of an equivalent to fibers in Ruby. And we just call f.get, which in turn will tell it to call the call method. So one thing I didn't mention is if you're running like these, if you're using web services as internal services, it's really useful to actually use a client that supports Keep Alive. And Eric recently had on his blog a post about how net_http isn't actually as bad as people say it is. You just need to use Keep Alive, and you get much better performance. So basically, it's not setting up a new connection every time you make a request.
He's wrong.
He's wrong. So yeah, unfortunately, I haven't yet programmed that into Typhoeus. What I'd like to do is make it so that it handles Keep Alives and also connection pooling, and maybe Wilson will do that. I don't know. Hopefully. Yeah. I promise I will be. So yes, but basically you want to wrangle a bunch of connections together and keep the a connection pool going. And this lovely piece of artwork was provided by Joe West. Thank you.
I was inspired by Luke's talk earlier.
So the last thing I want to talk about is stubbing. So it's really useful if you have a client library to, say we're talking about the entries system I was talking about. It just stores blog post entries or feed entries, and all you can do is you do gets to get specific entries. It's really useful if you have a method, just like a single method on your library where you can just say, stub this out. That way, in your initializer for your development environment, you can just call that method, and then at that point, hopefully it'll just serve up dummy data, so you're not actually hitting the services. And then, obviously, you want eventually to run a full integration, but that's, again, what your CI server is for, not your development environment. So, really quick review. Really, it's about writing readable client code. Other developers are going to come into your libraries, and they're going to look at them and try and figure out what to do. If you're abstracting complexity, they should be able to look at that library and not have to jump off to 2 different repos to figure out what you meant when you wrote that code. And if you do that, you're going to avoid a lot of frustration. So the other design, the design pattern I've taken is I have the models keep the logic for how they actually build a request, but they don't make the request. That way you can run parallel connections. And with all of this, you want to validate early. Any of those validations you can use from ActiveModel, make it so that you can validate before you actually make a call to the web service and save a little bit of time. And finally, don't forget easy stubs so you can abstract complexity and scale. And scale with the complexity of your code base and your team and avoid horrible monolithic applications. Thanks. Questions? You, sir. So I guess the question is, how do you manage shared models across applications or across different services? So the easiest thing to do is to actually just create a repo per client library. And then, so what I would actually do is I'd create a repo per client library, and then in the build task for the client library, have it uploaded to a shared space, like S3 or whatever, and then have in your Capistrano recipes and stuff like that, deploy hooks to grab whatever the latest versions of the gems are and put them in there. I guess the other thing you could do is you could, huh?
Just copy and paste.
Copy and paste, yeah. I guess you could also use submodules, but I always had problems with that, so I don't know. What do I think about Event.io and Node.js and basically the asynchronous model of programming versus threads? So I think asynchronous programming is awesome. Unfortunately, it does make your code a little bit more complex, I feel. But if you can get past that, I think it's a very good way to work. It gets you really good performance. I guess it doesn't. There's a bit of a debate. I think threaded models optimize for throughput, while evented asynchronous models optimize for max number of connections. So the question was, I had commented on how ActiveModel makes connections to the database for you, and I thought that was bad. Or Active Record, yeah, sorry, thanks. And that I felt that was stuff that was, it made more sense to put that kind of logic into a controller. So the thing about Active Record is that because it makes those connections for you, it makes it really, really easy to use. But at the same time, it kind of hides the fact from you that you're making these different connections. I think controllers are supposed to basically control the flow of information from one point to another, making those connections, while the model itself really is just about 1, data, and 2, business logic around that data, but not really connection logic. I know it's kind of heresy, but Java has this this design pattern for like a connection manager and like data access objects. And I don't believe in going that complex with it because it's very painful to work with. But some of that I don't think would be a horrible thing in more Ruby code. So the question was, I mentioned that partitioning would like, when partitioning, you need to take into account the frequency of joins between tables. So is partitioning something that I would recommend early or only as scaling requires? So yeah, I would say never, ever start a new app and build it with services. Because in a new app, things are changing so quickly, like you don't even know if you're building the right app to begin with. So chances are you're going to throw away a bunch of your code. And web services, like extracting things into web services is about taking things that are mature that you know you're going to keep, and you want to have them robust, and you want to be able to develop and architect them in isolation. So behind that like web services API, you could do things like change what data store you're using, you could change your queuing system or whatever, and nobody who is using that web service would have to know about that. Like that architectural complexity is hidden behind the API of the web service. And the thing is, like in the beginning of an app, you have no architectural complexity. You have like a database and app server and maybe memcache, but maybe not. So I would say never start with web services because it will just end in sadness and pain. Because they take a little bit more like effort to iterate on and improve. Because every time you change the API of a web service, you have to change the client library, and then you have to redeploy all that stuff. Which in a mature environment is fine, like that's okay, but in early environment it's, yeah, kind of pain. Okay, so I'll repeat the question first, which is, well, it's more of a statement, which is, if you have a bunch of different web services, then you have the problem of when you run your tests locally, if you're developing things in isolation, you can't be sure that you didn't break other things. Well, a few different things to this. One, use a CI server. Two, if you don't change your API, the ideal is that any underlying changes won't break your other stuff. As long as you have really good coverage of the API and you hit everything and you test all of that, you can be sure that when you upgrade that one service, you don't need to run the tests on all the other stuff, which is great, right? Because then if you have a huge complex app and you run the entire test suite every single time, like, yeah, that's great. That they were talking about increasing the speed of testing earlier, and I think that's great. That's awesome. But at the same time, like, it'd be great if you didn't have to run. Like Google, right? When they upgrade one part of their system, they don't run the test suite for all of Google. They run it for the small piece that you actually worked on. Right. So yeah.
And if I can just pitch in, one of the smells, like theoretically, when you the code base gets Ruby, you have to like partition and stuff. You should be partitioning them into parts that change at the same time and with the same frequency.
Right.
So if you have a lot of changes that hit 2 levels, you did it wrong, basically.
Right.
I mean, that's not really great advice once you've actually done it. But yeah, theoretically, you should not do that.
There was one other thing I didn't mention, and this just reminded me of it, which is there's nothing to say that this has to be, like you have to use HTTP-based web services. It could just be separate libraries that have some communication layer. I don't know, it could be anything. It could be Rabbit, it could be Rescue, I don't care what it is. But the point is you have like separate pieces that can be iterated on independently of each other and tested independently of each other. So, right, okay, I'll try and compress that into like one line. He mentioned that their current services deployment is very complex. Like deployment is hard, it's complex, and then there's the problem of how do you physically, like how do you split these up? Do you put them on different machines? Do you have like different processes? So in an ideal world where you actually have money for instances or servers or whatever, you achieve hardware isolation on your services. So that means each service gets, at a minimum, its own machine, and ideally a couple for redundancy. So again, like I said, this is not for new applications. If you're just running like 2 app servers and a database, then it'd be silly. Like, don't create all this unnecessary complexity. But if you're building a very large app where you're running many, many servers, and your code base is getting really, really large, then it makes sense. And then there was one other thing that you had mentioned, which is latency between machines. So if you're building like a bunch of, like this app like comprised of a bunch of different services, you do have to be wary of your call depth. So if a user comes into your app goes and hits this other service, and this other service hits this other service, and this other, like, basically you don't want to go like more than a couple of levels deep, because each new request adds a little bit of latency to the overall thing. But it's possible to design the system in such a way that you hit a ton of machines to service one request. Like, there's a statistic that said when you do a search on Google, you hit no less than 1,000 different machines to complete that search. And then Amazon, Werner Vogels, is the CTO of Amazon, has said when you hit the Amazon web page, it calls out to more than 100 services to build that single page. So it's possible to have a bunch of different services. You just have to make sure that you're not calling too deep. You're not chaining one after the other.
One of the key things about that approach that Werner would say is that you need SLAs in place in order to make sure that, like 99.9% SLAs, to make sure that they're responding in time. You actually build services off these that you build by other services.
Yeah, performance of the services becomes vitally important when you're using them to actually store your back-end data and also your business logic. It's kind of like, the performance of your database. Like, that's really important. Same thing with these services. You have to view them with the same kind of scrutiny. Anybody else? All right, thank you.